Alright, let's talk simplified radical form. So simplified radical form means there are no perfect square factors under the radical, and there are no radicals in the denominator of a fraction. So first off, radical is what we commonly know as the square root symbol. So an example of number 1 that would be an error is if we had, let's say, the square root of 45. The reason that's wrong is because 45 has a factor of 9, right? 45 is 9 times 5. And so therefore, root 45 is not the simplest form. And we'll talk about how to simplify that. Next, an example where we have radicals in the denominator of a fraction. Let's say we had 2 over root 3. That would be an error as well. We would have to simplify that by a process called rationalizing the denominator. So one big property that allows us to simplify radicals is this product property of square roots. It says for any non-negative integers a and b, the square root of a times b is the square root of a times the square root of b. In other words, we can split up the square root symbol into two separate radicals. So let's begin with a couple of examples. Here we have root 4 times root 9 times root 3. Well, root 4 times root 9, of course, is just 2 times 3 times root 3. So simplest radical form here would be 2 times 3 is 6 square roots of 3. Next we have root 36 times 3, which, of course, root 36 is just 6 square roots of 3. And then 108. So 108, I know that it's divisible by 3, because the sum of the digits is equal to 9, which is divisible by 3. And so root 108 is actually root 36 times 3, which, because of that product property, is the same as root 36 times root 3, which is, of course, 6 square roots of 3. And so this first example gives us kind of a rationale for why we should simplify radicals. Each of these examples, number 1, number 2, and number 3, they're all equivalent, although they look drastically different. And so in simplest radical form, we can see quickly that they are indeed equal in value. Let's try some more examples. Root 18, of course, has 9 as a factor. And so the simplest form here would be 3 square roots of 2. Root 20 has many factors, but 4 is the only perfect square factor. And so simplest radical form here is 2 square roots of 5. Root 150 has also a bunch of factors. 25 is the square factor we're looking for. And of course 25 is 5, so we'd have 5 square roots of 6. And then lastly we have root 32. So 32 is 16 times 2. And so the root 16 times root 2 would simplify to 4 square roots of 2. Now root 72, of course, that's just 9 times 9 times 8. So we could say, well, that's root 9 times root 8, which is 3 square roots of 8. But wait, root 8 has 4 as a factor. And so we can simplify this one step further. We could say 3 root 4 root 2. And root 4, of course, is just 2. And 2 times 3 gives us 6 square roots of 2. So if you ever get to a point where you think you're done, check to make sure that that radical symbol doesn't contain any square factors. Now the next example, 4 root 3 times 2 root 5. Remember, multiplication is commutative. And what I mean by that is we can multiply these numbers in any order. We have 4 times root 3, 2 times root 5. So I'm going to rewrite this as 4 times 2 times root 3 times root 5. Now the bare numbers out front, 4 times 2, of course, is 8. And the product property says root 3 times root 5 is equivalent to root 3 times 5, or the square root of 15. So 8 root 15 would be a final answer there. We'll do the same thing with number 10. 5 root 10 times 3 root 10. It's the same as 5 times 3 times root 10 times root 10. 5 times 3 is 15. Root 10 times root 10 is root 100. But root 100 is just 10. And so we're ending up with 150 as the simplest radical form, even though there's no radical in there. Here we've got number 11. Follows the same kind of a procedure. We've got 7 times 2 times root 3 times root 6. 7 times 2, of course, is 14. Root 3 times root 6 is going to be root 18. But root 18, we've seen that before. Root 18 can simplify to root 9, root 2. And so we have 14 times root 9, root 2, and 14 times 3 times root 2. We can simplify that down to 42 square roots of 2. Now this next example, number 12, is when we have a square root symbol in the denominator of a fraction. And so to kind of bump that out, we're going to multiply by 1. But it's kind of a strange form of number 1. Since we had root 5 in the denominator, I'm going to multiply by root 5 over root 5. In other words, a fraction that has a value of 1. I'm not changing what the original product was, but I'm just kind of changing the form. So now I have root 2 times root 5, which is root 10, over root 5 times root 5. Now root 5 times root 5 is root 25. And that simplifies down, of course, to just 5. So root 10 over 5 would be the simplest form here. Now let's take a look at that last example, 5 over root 7. Since we can't have square roots in the denominator, we'll multiply by root 7 over root 7. And so that gives us 5 square roots of 7 over root 7 times root 7 is root 49, which is, of course, just 7. And we're done. That's actually the simplest square root, simplest radical form. We have 2 more examples. Now with these, if you'd like, you can pause the video and try them on your own, but I'll walk through them as well. So pause now if you want to give them a try. So with this first one, 15 root 2 over root 3, we have to first rationalize the denominator. And again, what that means is I'm going to multiply by whatever square root I see in the denominator, I'm going to multiply by a form of 1. Now, on the numerator side, we've got 15 square roots of 6 over root 3 times root 3 is just 9. Sorry, root 9, which is 3. But now I see I've got 15 thirds. And that 15 thirds, equivalent way to write this would be 15 thirds times root 6. And 15 thirds is a fraction that can simplify down to 5. So 5 square roots of 6 would be the simplest radical form. And then this last example, first we'll rationalize the denominator, multiply by root 2 over root 2. On the numerator side, we have 4 square roots of 12. Remember, 6 and 12 make, or pardon, 6 and 2 make 12. All over root 2 times root 2, which is root 4, and root 4, of course, is 2. Now we can follow the same kind of simplifying fraction step that we took in the previous example. So that brings us to 2 square roots of 12. But remember, 12 has a perfect square factor. 12 has 4 as a perfect square factor, so we have 2 square roots of 4, square roots of 3, and root 4 is just 2, So we're multiplying 2 by 2, and 2 times 2, of course, is 4. So our final answer here should be 4 square roots of 3.